So now I'm going to explain how the change in the number of magnetic field lines through a circuit loop affects the magnitude and direction of the induced electric current. So as you see, the change in number of magnetic field lines will induce a current. So far we know that by moving the circuit loop into or out of a magnetic field that can induce a current line, and also changing the size of the loop or the strength of the magnetic field will also induce an EMF in the current. One way to predict whether a current will be induced in a given situation is to consider how many magnetic field lines cut through the loop. For example, moving a current into a magnetic field causes some lines to move into the loop. Changing the size of the loop or rotating the loop changes the number of field lines passing through the loop, as does changing the magnetic field strength or direction. So this chart that I've drawn is summarizing the ways of inducing a current in a circuit. The first is when a current is moved in or out of a magnetic field, either current or the magnet is going to be moving. So this is what it will look like before, and then this is what will happen after. Second way is if the current is rotated in a magnetic field, the angle between the area of the circuit and the magnetic field will change. So now this is what the before image will look like, and then this is what after it should look like in an inducing current. And then the last way you can induce a current in a circuit is if the intensity and or the direction of the magnetic field is varied, basically saying if the strength of the magnetic field or the direction changes. So this is the before image, and then this is what would happen after. And those are all the ways of inducing a current in a circuit. And when you're going to predict the magnitude of the induced EMF, you can use Faraday's law of magnetic induction, which is EMF is equal to negative N, and this all means the average EMF that is induced is going to equal the negative number of loops in the circuit times the time rate of change of the magnetic flux.